All right, so when you're doing this amusement park example, if you look at the code, all you really have to do is switch this Boolean expression using De Morgan's law. So it says not old enough and not tall enough. You basically are going to switch what's written here that I highlighted. Not a big deal if you know what De Morgan's law is. So real quickly, here's a recap. Hopefully you got it from the video, but if you need a recap, here's what De Morgan's law is. So let's say x and y are Booleans, right? So if you had regular x and y, the only way this would be true is if x was true and y was true. If either one of them is false, then the whole thing's false. So I want to know, this is what De Morgan's law is. If you negate or take the not version of an and statement, what is it equivalent to? Because sometimes this is a little too bulky to say. So we want to translate it because it makes more sense when you write code. So the not version of x and y translates to, I always think of it sort of like distributing, but this negation applies to every single piece, even the symbol in the middle. So a not version of x and y turns into not x, and I negate an and, which is like or, and then not y. Okay, so it flips everything. So if I say it's not the case that x and y are true, it's the same as saying either not x is true or not y is true. So, and then the other version is the or version, but it follows the same pattern. So you have, if I want to negate x or y, remember, if either x or y is true, it makes the whole thing true with an or, because ors are nice. You're going to distribute this negation to all the symbols and the things. So you're going to have not x and not y. So you're basically going to have to do that, but just translate it to this whole swimming and tall enough and old enough. And you're going to change that, and then you're going to change this line too. And try to make it with De Morgan's laws. Alright, so that's it for that one. Okay, and then the next question looks like it kind of wants you to do it in reverse. So it says don't remove this line. Which one are they doing here? It wants you to convert this to a Boolean. So you're going to do another conversion where you're taking it from here with the two not versions, and you're going to kind of do the opposite. It's still De Morgan's law, so if you start here, can you take it back to that? If you start here, can you take it back to that? That's kind of the deal on that one. Not hard, same idea. Try them out. Okay. Alright, so this last one is kind of a classic question where they ask, why doesn't this thing work like it should? You can run some code and see, like, if you enter an odd, let's try an even and an even. Okay, it says one number is odd, one number is even, so it's doing something wrong. If I try it again, I want to see if it messes up with an odd and an odd. Okay, that one seemed to work right. What about one odd, one even? Okay, that's not bad. And one more. So this is kind of testing to see where the errors are. Even, then an odd. Okay, so it looks like the only thing that was misbehaving was an even and an even, right? Yep. So I need to find out what's going on with that. So I go over here. The both even seems to be misbehaving. So analyze that code and try to see what's wrong. Both even would mean to me that you're going to try to return true only if this one's even and this one's even. I think they did that. Did they do the opposite? They might have. I don't know. Check that out. But you should be able to figure out which one it was, tinker with it until it works like it should, and you can just test every case. Right? You hit check code, see if they test it. So this one misbehaved on both even, isn't working right. So anyway, Give it a whirl.